And remember the condition that the power of the denominator is positive 1. So once more, the result is going to be ln of your denominator, ln f of x plus a constant. Of course, if you remark, we are integrating x power 3 plus 4x dx for the function which is 3x squared plus 4. The condition is satisfied. This condition is already satisfied. Okay, so I is going to be the ln of x cubed plus 4x plus c. Please don't be cheap with many steps, right? 4 steps as much as possible, right? As many rows as you can write, because it will be a guard for you from making any mistakes. If I go to this problem, and I went through this problem, which is really very simple, but there is only just one difference, that the power of the denominator is not positive 1. So the only thing is to check the derivative of this denominator. The derivative is supposed to be 4 of x power 3 minus 4, which can be exist, but actually it's missing just only 4. So all I have to do is to multiply by 4. So you will have 4x cubed minus 1. And divide by 4. And it is divided by x to the power of 4 minus 4x to the power of 3, which can be rewritten as 1 over 4 times 4x cubed plus 4 times the denominator, which is x power 4 minus 4x to the power of negative 3, integrate with respect to the x. The final result will be I equal to, adding positive 1 on negative 3 is going to be negative 2, so you will have negative 1 over 8 for x power 4 minus 4x to the power of negative 2 plus a constant, and you are done from this problem. If I go to the other problem, okay, this problem, as you can see, the derivative of the denominator, which is negative 2x, it doesn't exist on the denominator. This way I will have to memorize, yes, it's the inverse trigonometric functions, and it is satisfying this rule, integrating, this is a dx, this is the square root of 1 minus x to the power of 2, the derivative of x is 1, and it's almost there, so simply the answer will be arc of a sine x plus a constant, which is really a very simple problem to resolve. See, this is what I'm talking about. When you take the decision to use an arithmetic function, once you take the decision of adding a power, of adding positive 1 on the power, driving on the, and dividing on the new power, this is the points that needs your concentration. You have a lot of problems. I made a revision on the integration part. It has the rules in it. You will have to go through it. This is really confusing to some people. So you will have to first understand, when you use a arithmetic function, and don't you ever forget the law for this function, which states once you integrate f dash x divided by f of x and it's to the power of n shouldn't equal to positive 1 on this whole. So the integration simply will be I will equal to f of x to the power of n plus 1 divided by n plus 1 with a constant. Of course, remember, n could be positive, could be negative. This is the main law, so please do review it. You will have some problems on integration, of course. For this part, he is asking you to integrate these two functions. Once you start looking for the first of them, you will find x minus 5 times cosine x. And this problem, it can be solved using integration by parts. Once more, I will look to this case. This is going to be integration using by parts. And for this function, I will have to choose which one of them will be integrated and which one of them will be differentiated. This is the first case case 1 in partial derivatives, in integration by parts, I'm sorry. So I'm going to go for differentiating x minus 5 as it will disappear in the second integral, and integrating cosine of x. Simply the integration will be integrating cosine x, which is going to be sine of x times x minus 5 minus integrate. The integrating function or the integrating part will be inside this integral. For x minus 5, you will have to differentiate it, which is going to be 1. Once more, I will equal to x minus 5 times sine x minus integrate the other part, which is going to be cosine x plus a constant. We already integrated this portion, or you have the right answer for this problem. Going to the other square root or the other problem, it will refresh your memory. This problem is easily, or it's very, very simple, and you can solve it easily by using substitution. As you know. So, one of the ideas of this problem is to consider x, which is going to equal to 3 times sine t. You will have to pay the price for your substitution, for using it to make substitutions. You will have to get d of x. That's d of x is going to equal to 3 of cosine t times d of t. Start substituting. That's I. We're going to equal to integrate root of 9 minus, replace x by 3 sine t, which is going to be 3 sine t to the power of t, okay, times. Instead of having dx, we will have 3 of cosine t times dt. Once more, I will take 3 as a common, so you will end up having 9 integrate square root for 1 minus sine square t times cosine t times dt. We already made this substitution in order to take advantage of having 1 minus sine square. So we will have 9 integrate square root for cosine square t times cosine t dt. So we will have the form of this integral to be in this form. 9, open a bracket, which is cosine square t times dt. Once more, we will have 9 over 2, integrate 1 plus cosine 2t with respect to t. Start to integrate for the time being. So I will have I equal to 9 over 2 t plus sine 2t divided by 2 plus a constant. Don't you ever forget that once you make your substitution, you will have to reverse it. So from this, I can say that each t will equal to an arc sine minus 1 of simply x over 3. The final step, if you like to go for it, it's going to be simply 9 over 2 over the bracket replace t, which is going to be sine minus 1 of x over 3 plus a sine of 2 times sine minus 1 x over 3, and all of this is divided by 3 plus your constant and your other. These are also two of the famous ideas of integration, either integration by parts or going through the integration by substitution, as you can see from this problem. Okay. Also, we can take advantage from some of the properties of the definite integration, which will depend on like the first problem. For example which states that we will integrate from negative 2 to positive 2 for 2x squared plus 4 of dx. Remember the property that states that if we integrate from negative a to positive a for f of x times dx, if f of x is an even function, or f of x if it was an odd function. If f of x was an odd function, the integrand or the integration will be equal to 0. But if it was an even function, simply we can rewrite it this way. We can say that I equal to half of the integration times f of x dx, and it will be simply equal to it. So all I have to do is to integrate 2, start from 0 up to 2 for 2x squared plus 4 times dx. Start integrating, so you will end up having 2 over your bracket. It's going to be 2x to the power of 3 divided by 3 plus 4 times x. Start substituting from 0 to 2. So you will end up having 2 over your bracket. It's going to be 8 over 3. So actually it's going to be 16 over 3. Then plus 8, which simply can be rewritten as 24 over 3. And you will end up having 80 over 3. That's the right answer for this problem. The other problem, it's a joke. I'm just joking and kidding me. I'm just integrating from 2 to 2 for x plus x squared. I thought this is a very nice problem, and it's going to be very nice for you if you know this property. The answer is no. Degrading from a to a for any function f of x whatever is going to equal to 0. So simply you can just state that I equal to 0. I thought it's a very nice idea to just go through it with you. Okay. This was for the definite integration, and you have these problems. Here's asking you for the mean value theory, just verify, just state it, and then apply it on sine square. I was shocked that just really very few of you could solve this problem. It's supposed to be a very simple problem for you. All you have to do is write the mean value theory law and you substitute in it, and you will be done. Let's see. If I want to solve this problem, simply, if you have f of x, which belongs to from a to b, and you want to get your mean value, it's going to be 1 over b minus a. Just integrate from a to b for the function f of x dx, and simply you will get your value. Substituting within this interval, so it's going to be 1 over y minus 0, integration from 0 to y. I replace f of x by sine square x dx, assembled, and it had been done plenty of times. We did it a lot. You can't integrate sine square, but you can simply replace sine square by 1 minus cosine 2x divided by 2. So you will end up having 1 over 2 pi, integrating from 0 to pi of 1 minus cosine of 2x, which is just left to x. That's going to be 1 over 2 pi, open your brackets, going to be x minus sine of 2x divided by 2. Make the substitutions from 0 to y. You will have 1 over 2 pi times pi. You will end up having the half, which is the mean value for this problem, and it has 10 marks. I've already indicated 5 marks for writing or remembering the main law, and 5 marks for handling this application of this problem. It's really very simple. The shocking that not a lot succeeded in dealing or solving this problem in a correct way. Okay, so this is for this problem. Here he is asking you about the area of y equal 4 minus x squared and the x-axis, which is really a very simple problem. Also, he is asking you to use an appropriate method in order to make or to apply the trapezoidal rule in order to get integration of this function, which is not, you can't find the analytic solution for this function. It will be solved numerically. So if I want to find the area using for this problem, the first step is to sketch this function, which is simply can be done by a lot of methods, but of course through this module you already have functions. So I will start with y equal 4 minus x squared, which is, if you like, of course, it's a second degree parabola symmetric about the y-axis. The axis of symmetry is x-axis. If you don't know or you don't want to go through this knowledge and you are a more safer person, you want to go the safest way, let's put it on the m4, which is simply going to be y minus 4, which is going to equal to negative x minus 0 to the power of 2. So simply the vertex will be at x equals 0 and 4, and the curve will be downward since this sign is negative. So this is mainly your function. I will need these 2 points in order to find the area enclosed by my curve. In order to find these points, I will have to solve the 2 functions together, or the 2 curves together. The x-axis, which is simply y equal to 0, and the function, the main function, which is y equal 4 minus x squared. Solving these 2 functions together will develop 0, 4 minus x squared. You will end up having x, positive or negative 2, which makes sense. This is negative 2, this is positive 2. If I need to get the area under the curve and the x of integration, I can integrate. As you can see, this is an even function, and the area is just only under this curve. So simply the area will be integrating from 0 up to 2 for the function, which is simply 4 minus x squared, and the integration will be with respect to x. I've taken just half of the area of integration and I will multiply by 2. So simply it's going to lead to 2 of 4 of x minus x cubed divided by 3. Then I will make the substitution from 0 to 4. You will have 16 minus 4 to the power of 3. I'm sorry, 2. Remember these same states from 0 to 2. So we will have 16, as I told you. And this is 2. And then we will have 8 over 3. It can be rewritten on the form, which is going to be 16 times 3. I believe it's going to be 64. Yeah, 64 minus 80 is going to be 54 divided by 3. Okay, make the substitution for this function to get your area directly. 48, it's going to be, just a second, with this problem, it's going to be 2 of 48 minus 8 over 3, which is going to be 80 over 3, and you can get your answer. And this is for the area part. You will have to review it, you will have to solve problems about this part too. Of course, here is dealing about the trapezoidal rule. If you want to solve this problem, it's also very, very simple. All I have to do for this problem is to identify h. Remember the trapezoidal rule, which states that I will have to get h, which is b minus a divided by n. Here the integration limits is 1 and 0, so 1 minus 0, and he needs you to expand it about n equal to 10. So h is going to be 0.1. This is 0.1 you will have to get. Then I will write that I equal to h over 2, open your bracket, f at a plus f at 3 plus 2 of f f of a plus h, then f of a plus 2h, then f of a plus 3h, blah blah blah, till you reach n minus 1, and you will get your value. And we will start substituting. So I 0.1 over 2. Here f of x that we are dealing with in the function in the integrand, we are talking about this function which is e to the power of negative x squared. So simply it's gonna be, once you replace x by the integration limit, which is 0, so it's gonna be 1. Then plus f of v, and we replace x with positive 1, so it's gonna be e to the power of negative 1. Then plus 2, open your bracket. E to the power of negative 1 to the power of 2, plus e to the power of negative 0.2 to the power of 2, plus e to the power of negative 0.3 to the power of 2, blah blah blah, till you reach e to the power of negative 0.9 to the power of 2. Start closing and evaluating your integration, and you will have your right answer in the palm of your hands. Very, very simple, very quick, to the point, so it's a very nice problem, okay? You will be also asked to get a numerical integration for some functions in the final exam. Bottom line, I've told you that your final exam will cover literally everything that we did go through our course. Here he is asking you to simplify a couple of questions, which is really very simple. Really, very, very simple. If I want to go through the first problem, he's asking you to put it on the simplest form. All I have to do is to multiply both the numerator and the denominator in the conjugate of the denominator, 3 plus 2i, 3 plus 2i. So z simply will equal to 3 times 3, which is going to be 9, negative 2 times positive 2i, you will end up having negative 4 of I squared. Going to the denominator, you will have 5 times 3, which is going to be 15. Then I times 2i, which is going to be positive 2 over I squared. This part will be real. And on the other and for the imaginary parts, you will have 3 over I plus 10 I. You will have 5 times 2i, 3 times I in this way. So you will end up having 13 plus 13 of I. All of them divided by 13, you will have 1 plus I, simply z, and there is 5 marks dedicated for this problem. The problem on the other side, it's exactly in a similar manner. All I have to do is to get first the value of z simplified as much as possible, which is simply going to be 1 plus 2i, 1 plus 2i. You can use either Euler in order to make them easier, but I will go for the simplest way. So simply z is going to be 5 for the denominator. For the denominator, it's going to be 2. It's going to be 2. Then you will have plus 2 over I squared. Then you will have I and 2i, which is going to be 5 of I. Once you replace I with I squared, these two parts will be replaced together, will be cancelled together. 5 also will cancel 5, so z will equal to I, getting the value of z cubed, which is going to be, which is going to be simply I to the power of 3, that's negative I, and then you will have uniform mark for these two complex problems. Review them. You will be asked to find values of z, taking nth derivative, z to a power, whatever. You will have to review it. It's a very simple part in our video. The last problem, here also, this problem is really very simple, and it's also indicated for the complex. Remember, I'm getting a fifth root for the value of z, which is 32. if I want to start solving this problem, I will have to start from this point. It's really a good problem. We'll start with z to the power 5, which is going to equal to negative 32. Okay, I want to have the values of v. Let's first move to the polar representation for this function, which is simply, if you remember, this is the real x and this is the imaginary x. Negative 32, which exists in here, and for this complex number, it's negative 32 plus 0 times I. This is the complex number that we are dealing with. So the angle is also starting from the positive direction of the x-axis and going anti-clockwise. So theta is going to equal to pi. I will need to get r, which is simply the square root of the real part, negative 32 to the power of 2 plus 0 to the power of 2. So it's going to be 32. This is r. And for theta, once you have it here, it's 10 minus 1, which is represented by negative 32. So now I know that theta equal pi. We already know that if I want to have z, the nth root is going to be r times r to the power of over n times cosine theta plus 2 pi k divided by n plus I times sine of theta plus 2 pi k divided by n, and this is the form for the nth root. Start substituting. That's z is going to equal to 32 to the power, as we are getting the fifth derivative, to the power of 1 over 5. Open your bracket. It's going to be cosine pi plus 2 pi k divided by 5 plus I times the sine of pi plus 2 pi k divided by 5. Don't forget that k will take the value 0, 1, 2, 3, 4, and these are the 5 roots. So all I have to do is to state that for k equal 0, for k equal 1, for k equal 2, then you will have z1, z2, z3, which is gonna simply, and so on. For the 5 roots, we'll start by 2, 2, 2, then open your bracket, you will have cosine of just only pi over 5 plus I of sine pi over 5 for the first root. For the second root, it's going to be cosine pi plus 2 over pi over 5 plus I of sine of 3 pi over 5. For the root after that, it's going to be pi plus 4 of pi, so then be cosine 5 pi over 5 plus I sine 5 pi over 5, and so on. Those are the main angles and the results related to it. Okay? Once more. Okay. Here the final problem, which is problem number 10, and it is required to solve this system of equation using grammar. As I told you here using grammar, as I told you plenty of times before dealing with this system, which is really very simple one, you will have to be sure that your equations or the system is perfectly ordered over. As you can see, I have, let's use the blue pen, I have x1 here, x1 here, x1 here. Okay, I will try to put it on the matrix form first, then and we'll arrange them also while we are writing them. We will have the following. We will have 10, then negative 3, then 5, and for the values of x2, I will have negative 7, then positive 2, then negative 1. For the x3, we have 0, then I will have 6, then we will have 5. This is for the coefficient matrix, the unknown matrix, which is x1, x2, x3, and for the result matrix, which is going to be 7, 4, and 6. This is mainly the main function. I will get the values of x1. x1 is going to be, I will put the determinant of the coefficient matrix first on the denominator, which is going to be 10, negative 3, and 5. This is going to be negative 7, 2, and negative 1, 0, 6, and 5. In a similar manner for this is x1, for x2, similar manner for the denominator, which will contain 10, then negative 3, you will have 5, negative over 7, 2, and negative 1, 0, 6, this is 0, 6, and 5, and for x3, it will be, let's write it here, and for x3, it will be in a similar manner, okay, in a similar manner, 10, negative 3, then you will have 5, negative over 7, this is 0, 2, negative 1, this is 6, and 5, this now. But for the denominator, since we already know that x1 equal delta 1 over delta, or the determinant of the coefficient matrix, and similar for x2, delta 2 divided by delta, and also for x3, which is delta 3 divided by delta. I will start writing the right values for the determinants. I will start with taking 7, 4, and 6. Also here 7, 4, and 6, and also 7, 4, and 6, and we are done. You can now get the values of your determinants. The other columns will be the same, negative 7, 2, and negative 1. For this 0, 6, and 5. Similar manner, it's going to be 10, then negative 3, then 5, then 0, 6, and 5. And almost the same way, 10, negative 3, this is 5, that's negative 7, 2, and negative 1. I believe this is going to be 155 over 155, as I remember. Please do check that. This is going to be negative 155 over 155, so it's going to be negative 1. I believe this is going to be positive 1. This is going to be 0 over 1, which is going to be 0, and now you can solve them. Of course, evaluating the value of the determinant, you can use either Sarah's rule, which I explained previously. I will go through the principal diagonal, which is 10 times 2 times 5 plus. Take the lower base or the base of the lower triangle times the head or the vertex of the upper triangle. So it's going to be negative 3 times negative 1 times 0, then plus, in a similar manner, the base of the upper triangle, negative 6 times 6, and it will be times 5, the lower base, minus, do a vice versa, 0 times 2 times 5, then plus 6 times negative 1 times 10, 6 times negative 1 times 10, then negative 7 times negative 3 times negative 5, negative 7 times negative 3 times 5, close it, and get the value for each one of these determinants, and you'll get the result. My dear students, going through all this, you will remark, I stick to the idea in all times that all the courses that I'm supporting or I'm working as a module leader for all of these modules, you will have to go through the necessary steps that we said previously. All our course starts, first of all, from the first chapter till the end of our course. All the ILOs will be met. So please study well, and I hope you will get the highest grades that you wishing for. Thank you. I enjoyed it. I wish you all enjoy these parts of the revision of our module. If you have any questions or further inquiries, please feel free to leave it on Teams or Canvas or whatever. You can contact me. I will be in my office hours here in the university. Thank you very much. Enjoy it, and the best of luck for you all. Thank you.